This is the intro video for Algebra 1, and we're going to be looking at the concept of polynomials, and specifically here, polynomial terminology. All right, so a couple of fill-in-the-blanks here. Polynomial is a single term or sum of terms in which all the variables have whole number exponents and no variable appears in the denominator. So here are some examples of polynomials and some specific names. All right, so these are all on the left side here. These are all monomials, and please notice that they all have just a single term. That's why it's called monomial. It means one term. Binomials, next column over. These are all examples of binomials. So I'm going to highlight the terms here. Please notice that that first binomial has two terms. Second one, two terms. Third one, those are two terms. Of course, the third one there, the terms are a little more complicated. They both involve like an A and a B. They're still just single terms. Separate terms are separated by addition and subtraction, and a term is held together by multiplication or division. Okay, then we have a column over here of trinomials. So again, I want to highlight the three terms here. Trinomial means three terms, just like binomial means two and monomial means one. So there's one term, two terms, three terms. There's one, two, and three. One, two, and three. It doesn't really matter how complicated a term is. If it's just a single term, it's just a single term. So got three single terms there for all those, so it's called a trinomial. Once you get past three terms, they don't really have a special name for it. So if you notice here, I think these all have four terms. So 1, 2, 3, and 4. And I think you can see the other ones there have four terms as well. So again, once you get past three terms, we don't have a special name like trinomial or binomial. All right, so we want to make sure that we'll be able to identify those. We're going to look at a little bit more terminology here about concerning these polynomials. Okay, so the first term here is descending order. So descending order has to do with the exponents. So if I had a polynomial that was, say, 2x plus 7x squared minus 9, I would say that that is not in descending order, because notice that the exponents on the variables go from 1 to 2 to technically 0. The exponent on that variable is just a 0. We'll get into that a little bit later. But for now, let's focus on the 2 and the 1, and the fact that the 9 doesn't have a variable. To write this in descending order, I would say 7x squared plus 2x minus 9. Notice how the variables go from 2 to 1 to there is no variable. So the exponents on the variable have to descend in order for the polynomial to be in descending order. Lead coefficient. Well, if a polynomial is in descending order, the lead coefficient will be the first coefficient you come to. So if I had 7x squared plus 2x minus 9, I'd say that my lead coefficient is 7. It's got to be, the polynomial has to be in descending order for this to be true. So maybe another example here would be if you had 2x squared, let's actually make that 5x squared minus 8 plus 4x to the third minus 12x, or something like that. It might be tempting to look at that and say that the lead coefficient is 5, but that's not really true because this polynomial is not in descending order. So if I put it in descending order, I would get 4x cubed plus 5x squared minus 12x minus 8. And now the lead coefficient becomes a little more clear. The lead coefficient, now that we're in descending order, the lead coefficient would be the first one. So lead coefficient in this case would be 4. Okay, two more terminologies to talk about here. The first one is degree of a term. The degree of a term is the value of the exponent on the variable. So for example, if I had 9x squared minus 4x plus 12, I would say that the degree for this first term is 2. So I'm looking at the exponent to get this. Here, I'm going to say that the degree is 1. Again, I'm looking at the exponent on the variable. We understand that to be a 1. And then lastly, for a constant like this, the degree is going to be 0. And again, we'll get into a little more detail about why that is as we move forward. Okay, and then finally, the degree of a polynomial. So the degree of the polynomial is the same as the degree of the highest degreed term. Okay, so if I had negative 11x to the 4th plus 9x squared minus 8x plus 7, if I look at my degrees here, I've got degree 4, degree 2, degree 1, degree 0. So the degree of this polynomial would match the degree of the highest degreed term. Well, highest degreed term is right here. It's x to the 4th. So this polynomial would be degree 4. Okay, so when you come to class, we're going to practice this terminology a little bit, hopefully get it real solid for you. I'll see you then.